one of the projects that we worked on, there's literally one piece of equipment in the whole US. And we need to rent that and align that works with the other projects that they're trying to rent that out to, for example. That's a bottleneck for us.
Hey, Karl, how's it going?
Things are going great. We just had the inauguration yesterday. So Donald Trump is back in office. He said, drill, baby, drill, talking about liquid gold. What do you think that means for climate and biomanufacturing?
Oh, yeah. Oh, my God. My heart sank. I was washing the dishes when I was listening to the inauguration in the background, and I'm like, no. And hey, everyone has a place. Petrochemicals has a place in our world of resources, but we use it too much. We use petrochemicals so much. And have we learned nothing from the plastic garbage patch in the Pacific? Have we learned nothing from what's going on in our atmosphere and climate destabilization? I can't say climate change anymore. That term is gone now. So now we're saying climate destabilization, or we're saying extreme weather events. Fine. It's all the same thing. And it's just so insane that we can't come to consensus on it. It boggles my mind. But my thing is is there a silver lining here? What are the oil companies going to do? I don't like the idea to export it to other countries, but hopefully other countries are we know that this is probably not the main resource that we need. We need some of it, but not to just fuel everything, all of our materials, all of our energy. Just use a bit of it. Our podcast is about biomanufacturing and growing everything. We want to have a nice mix of different materials and ingredients and resources to use to build the things and make the things that we use every day.
Okay, so the silver lining is that the synthetic biology industry was born of the failure of biofuels, which was people trying to replace petroleum and petroleum products with synthetic biology. And there was an enormous amount of money that was poured into synthetic biology 1.0. And from that, a lot of companies were born. I agree with you. We do know that the big petrochemical companies are the number one investors in alternate resources. And we also see people who are creating alternate plastics, and they're coming on board pretty quickly. I don't know. Drill, baby, drill, I think is a political thing. I think Trump leaned heavily on the oil industry to get himself elected. And so he has to do that. I think we just have to watch it. What we do know is that biomanufacturing is strategically very important. It's a very important driver of the economy. A lot of the initiatives that we talk about on this podcast happened during Trump 1.0. So I think from a competitive advantage, from a security advantage, from a supply chain security advantage, we're going to continue to see a lot of money pour into biotech and the bioeconomy.
And again, I'm saying, we don't want to get rid of petrochemicals. We just want to have a balance. And I think the advantage of biomanufacturing is that we can have higher functioning materials and packaging. So once consumers start seeing that and feeling it, then there'll be more of a demand. We've seen that with K18. We've seen that with other companies that are making bioplastic or compostables, and people are purchasing those things. We needed to scale up more. It remains to be seen on how we get more of a demand out there. And I think things like our podcast and other people that are sharing what's possible when it comes to biomanufacturing. Again, sustainability in biomanufacturing is table stakes. We are talking about better functioning products and, of course, at a cost that is compelling and on par with what we're used to spending. But this lines up with a pledge that I took over the weekend. I went to the New York Aquarium. They have this exhibit where you can take a photo of yourself and they put you on this ocean magazine, like a graphic of it, but you have to take a pledge before they publish this graphic of you on this magazine. My pledge is not to use single-use plastics because that is a core of a lot of the damage because of volume and just being thrown away like that. So I'm doing it. I'm done with plastics as much as possible. I'm going to try, but then I start seeing it everywhere. I didn't pay as much attention, but now that I'm trying to take this pledge seriously, even though it was more of like a fun museum thing, I'm like, wow, it's everywhere. But if it's long-term use, okay, I'm fine with that. So let's see what happens with the battle of resources and where are we going to lean? Can we be large-minded, not small-minded, just to use petrochemicals? Can we think bigger and think as engineers and designers to use a variety of different resources, not just petrochemicals?
Yeah. Good luck. Erum, it's hard. I know it's hard. All of our houses are full of plastics. We've got clothes that is full of plastic. And I think anything we can do to make a contribution really does matter. Individuals have to set the example, and we have to force companies to do these kinds of things. It just might be a little bit challenging now for a bit of time, but that train has left the station. So I don't think that it's going to stop just because of one person or one administration. But we shall see. Mm-hmm. So you had a couple things in the news. So tell me what was of interest.
Well, the big thing in the talk of the LinkedIn town of our network has been Colossal Biosciences raising $200 million at a $10 billion valuation.
Yeah, it's crazy.
Someone had posted about it, and there was a lot of comments from people that we know that were like, this is just capitalism at its finest, overvaluated. They said Colossal Biosciences efforts have been vaporware. A lot of the conversation is about Colossal's North Star is to de-extinct the woolly mammoth. But you know what, guys? We've had people on the podcast that are associated with Colossal, whether they're on the board or were early part of it. We had Alexander Titus, Chris Mason. They're affiliated with this organization. And it's not just about bringing back the woolly mammoth. There's a lot of nuance. And then they're doing a lot of research on being able to create external wombs or different types of technologies, different types of engineering technologies that are so challenging to make. It's not as black and white, like they're just raising money and doing nothing. I don't think that's what's happening here, but I think we'll have to have someone come on and talk about it more.
Yeah, I think we should. I mean, if you've read the novel Jurassic Park as opposed to seeing the movie, one of the things that becomes clear early on is there is a company that is buying up a bunch of technologies. And that's the company that does end up doing Jurassic Park, bringing back or de-extincting the dinosaurs. But there is a subplot, or maybe it's just mentioned in a couple paragraphs, where the company that has external wombs, a company that has developed a way of fertilizing certain kinds of eggs. Mm-hmm. And it's going to take a lot of technology to bring back these woolly mammoths. So it would make sense that if Colossal is demonstrating that they are developing these proprietary technologies and they have multiple applications, then that raise makes sense. And the valuation seems a little frothy to me, but we got to see, let's get them on here to talk about it. And let's see some proof out in the marketplace that it's not just about the woolly mammoth.
Yeah, that's true. I mean, Chris Mason said this is a North Star. They have to make these technologies, but those technologies, again, gene editing, external wombs, these are healthcare technologies.
Yeah.
And so when we talk about healthcare and even gene editing on the therapeutic side, pharma does have very big valuations, and then they make good on those valuations because they sell a lot of their therapeutics all around the world. So yeah, we're going to dig into this for you guys, and we're going to find out some more information. Haters going to hate, but we'll see.
We're going to do what we can to find out.
Yes, exactly. What else has been going on, Karl?
Well, there were two things that, like you pointed out, that Perplexity had put in a bid for TikTok, I think right before TikTok went dark, and then TikTok 12 hours later came back online. So I thought that was crazy drama right before the inauguration. But I thought it was interesting that Perplexity would vote on them because we think Perplexity is being more of a research tool. I think one of Perplexity's big bidders is NVIDIA. So that didn't really go anywhere, but I guess we'll see because there was a whole consortia of billionaires who are going to put their money together to buy TikTok.
Yeah, it's unfolding as we speak. But as soon as I heard that Perplexity is bidding for TikTok, I'm like, that's interesting. What if a social media was just focused on science, biology, and experimentation, and it was fact-checked, it was discussed? I don't know if there's any tools like that to the level of user experience of TikTok where it's videos and, editing tools and just scrolling and all the things. That user interface with content that drives scientific discovery would be so cool. That would be something that maybe I would be afraid of actually too, because I would probably be addicted to it. I would want to dig into geology, no pun intended, but I would want to be able to learn about different sciences from people that are doing it in the field and that they talk about it in a way that is accessible, kind of like what we do here at Grow Everything, so that more people can just get a hold of it and start maybe doing their own research. Or just like there's a viral event like the Ice Bucket Challenge, everyone was doing it. So to be able to have a global campaign for scientific discovery would be fascinating. And that being fueled by AI to be able to help provide the right information. So the algorithms designed to be able to feed you sciences that you're interested in. So for us, we would see a lot of biological sciences, but for others, they would see the science that they're interested in. So a girl can dream, but that got me thinking.
Yeah, I mean, supposedly there's 8 million scientists on the planet, so it's like 0.1% of the total population. Mm-hmm. So I think that it's up to us and scientists to really leverage the existing channels as much as possible and to maybe create our own channels on them, which is something that we've been doing or trying to do. What I thought was interesting about this was also that Perplexity is highly funded by NVIDIA. And then NVIDIA, who we've had on this podcast in the past, has been very active in working in drug discovery. And actually, they just made an announcement with the ARC Institute, who we've also spoken about, where they're bringing advanced machine learning tools and models to scientific discovery. One of the things that we talk to people about and then we hear over and over again is what's going to be interesting as these tools are applied to biomanufacturing.
Yeah, we saw Patrick Sue present at Beta, and wow, it was incredible discussion about whole genome sequencing and what is required. The idea that, of course, we talk about it often, the genetic code of life, the ATGC, similar to the zeros and ones of computation. And that's just the beginning of the code. And we're learning the letters, but we haven't learned how to write the story. That was something that Patrick Sue shared on stage. That is where we are now. But with NVIDIA supporting the ARC Institute, sounds like there needs to be a little bit more big players in between, because NVIDIA's core competency is the GPUs, but they are making open source tools for scientific discovery, like you just mentioned. So it's going to be exciting to see, is this the beginning of that whole genome writing that we've been talking about with Chris Mason, with Andrew Hessel that was on the podcast? We're going to keep an eye on it, and we're going to be talking to the people in our network that would be leveraging these types of tools and seeing what they can make. A lot of the talk with the tech industry is so deep tech-wise that we need to be able to bubble that up to the surface and envision what can happen. We can say, yeah, AI, and then there's therapies, but there's so much that happens in between. And that's what we want to bring to you guys, to be able to talk about how to unravel the complexity that is from the deep tech to the consumer world.
Yeah, and I think that's a perfect segue to our interview today, which is with Noah Helman of Industrial Microbes. And Industrial Microbes is focused on making biomaterials, which is exactly what you talked about earlier, Erum, using renewable low-carbon feedstocks.
That's cool. So how do you know Noah, Karl? When did you meet him?
So I've known Noah for a really long time, actually. We had met through Gen 9, which is an early DNA synthesis company that was started by George Church and Drew Endy. Gen 9 had a contest where they were awarding DNA to different companies, and Industrial Microbes was one of those companies. So I did end up meeting Noah through Gen 9, but then we were on a panel together at Beta, I don't know, in 2016 or 17. Felt like a long time ago. We've followed each other's careers since then. I know that Industrial Microbes just raised like $10 million at the end of 2024. So it felt like this was a good time to bring them on. So why don't we let Noah tell us the story of Industrial Microbes and take it away. All right, Noah Helman, Industrial Microbes. We're so happy to have you on the Grow Everything podcast.
Thanks so much for inviting me. Really happy to be here.
Yeah, you and I got introduced to each other through Gen 9, which was an earlier DNA synthesis company. And Industrial Microbes at that point had won an award and received a bunch of free DNA. But before starting Industrial Microbes, you were part of Symbio 1.0, if we want to call it that. Can you describe what that was, what it means to you, and maybe some lessons that you learned from that? And how do those lessons apply to where we are today?
Symbio 1.0 for me was a big shift in thinking about what my career was going to be and where we needed to try to make a difference in the world. I think they were heady times. There was so much excitement around all the different companies that were getting started and funded and even going public. Not that LS9 went public. We were in some ways the little sibling of Amyris and Solazyme here in the Bay Area. But I just remember a huge amount of optimism, and that bore out in bringing a bunch of terrific people into the industry. And certainly one of the things that I took away from that period was how important it is to work with really great people, smart, motivated. We were coming in on the weekends, staying late, or in my case, getting to work really, really early to miss some traffic coming across the Bay Bridge. And we had incredible technology that hit all these technical milestones. We were making product and sending that out the door to partners for testing. And at the same time, reality came in and bit at a time that oil was really expensive and everybody was excited about replacing it, but then it seemed like things shifted. And obviously that was outside of our control, but it did have a major impact. And suddenly the challenge of what it meant to compete for such large markets and these products that were very cost sensitive, that all came to crash down on top of us before we knew it rapidly.
Yeah, the whole biofuels story is a very interesting case study. And hopefully we're learning from that. There are obviously new companies that are spinning up with new technology. And I would love for us to dig into that. But you've been a part of this SynBio world for some time, and now you're at Industrial Microbes. Can you tell us what led you to start the company?
While I was at LS9, as I mentioned, there were some incredible people there. And two of the people that I met were Derek Greenfield and Liz Clark, who are now my co-founders. We've been at Industrial Microbes for over a decade. Back then at LS9, we were scientists at the bench working to make these technologies happen and bring them to market. But we weren't really thinking that much about what the economics were and how that impacted everything. When that reality came to our front door, it was sort of like once bitten, twice shy, maybe. I think we realized that we really need to pay attention to this. We started thinking about that problem much more like engineers, I guess. If the problem is cost, where does the cost come from? Well, it turns out the cost comes from two main areas: the cost of feedstock and the cost of the purification, getting the product to the right spec. So we took that and tried to think about what could we do to address that problem very directly. Could we come up with a technology that would allow us to switch to a different feedstock and eliminate some of those cost problems, while at the same time checking all the boxes on things like sustainability and getting to low carbon emissions or a net zero process? And it was that process of ideating, how can we solve that problem, all of those things at once, that led us to reimagining using different feedstocks for industrial biotechnology, specifically C1 and C2 feedstocks. So things like methane and methanol, as well as ethane and ethanol. That was the initial set of work that we started out to pursue.
And you guys, at the end of 2024, announced that you had raised $10 million. And in the news, it said to transform biomanufacturing. What does that look like? What is it you guys are focused on?
Right now, we're focused on using a new feedstock, so specifically ethanol as a feedstock, to make chemicals and materials at cost-competitive prices that are net zero emissions and can come from sustainably sourced ethanol. With the recent fundraise, as you would expect, we're building out the team and more capabilities inside our lab and focusing on scale up and developing partnerships and moving much more rapidly towards commercialization through that scale up process. And we just brought on a great VP of business development, Matt Engler, who's helping to set up partnerships for us throughout the industry. So we're moving that technology that the team has already developed further towards the efficiency that we need to hit in order to really commercialize that, and in parallel, setting up the types of commercial relationships that we need to bring that to market.
Yeah, I mean, we would love to learn a little bit more about what type of materials are being made with the ethanol, what type of microbes are you using in general. I mean, we would just love to imagine a little bit more on how you're growing materials using ethanol through precision fermentation, which we do talk a lot about on this podcast. But you specifically, we would love to learn either what can be made or what you're making today. Help us visioneer that.
Absolutely. So our first set of products is going to be made using a single bioprocess that converts ethanol into a polymer called poly-3HP, which accumulates inside of our cells. And we're using E. coli. The advantage of doing that is simplifying the purification and conversion process to the final product. In our case, the first product we'll be going after is acrylic acid, which can be made from that polymer using a very simple process. Essentially, you just heat it up and separate the vapors using distillation, for example. That checks the boxes on, as I mentioned initially, trying to reduce the feedstock and the purification cost by simplifying the process. So by developing one bioprocess that gets us to this polymer, we can use a chemical process, basically heating it, if very simple process, to get to acrylic acid. We recently started a second project to take the same polymer to acrylonitrile. That way we can use the same bioprocess, but just shift what happens in the downstream conversion to get to a different product. And then we can make, in this case, carbon fiber from acrylonitrile that we can use as a sustainably sourced carbon fiber.
Oh, wow.
Yeah. You said you're using ethanol for those?
That's right.
Where's that ethanol coming from?
Well, one of the reasons we're really excited about ethanol is it can come from a bunch of different sources. So, of course, today, ethanol in the US is mostly made for the fuel market. At least here in California, it's about 10% of our gasoline blend, as many other places in the US. And it mostly comes from what they call first generation corn ethanol, where corn that isn't going to be used for human consumption is used as an energy crop and is turned via fermentation into ethanol. And we can leverage that infrastructure to be able to use their ethanol as a feedstock for our fermentation process. And then through a very efficient pathway, get to this polymer. Actually, in the case where we get to the highest theoretical limit of that process, we can consume an ethanol and a CO2 molecule in order to make a 3-carbon molecule that's used to make the polymer that accumulates in the cell. Ethanol in the future can come from a variety of different sources. You're probably familiar with cellulosic ethanol, where agricultural waste can be converted into ethanol using, again, a fermentation process, very robust microorganisms. And more advanced technologies are still coming online. So companies like Enerchem take municipal solid waste, or basically landfill waste, and gasify that into syngas and then turn into ethanol. LanzaTech, Sonata Bio, and others are using biological processes to take syngas from industrial off-gas and make ethanol. And then there are papers coming out every week, basically, on the direct electroreduction of CO2 into 2-carbon molecules, including ethanol. So we're very excited about the idea of ethanol being a building block feedstock for the chemical industry and for the biomanufacturing industry as well. And so we're trying to anticipate that's where things will go in the circular economy that we see is starting to develop.
I just want to ask one quick follow-up on that. What does that look like, electrifying waste to turn it into ethanol? You said there's papers about that. I've heard people talk about that in the past. And I was like, well, when's that going to happen? Being a little bit skeptical. And then you have people saying, well, once you reach marginal zero cost energy, it'll change the game when it comes to feedstocks and how we do industrial biomanufacturing. What does that look like today?
The work that's being done on direct electroreduction of CO2 to ethanol is still, I think, pretty early days. If you're familiar with the company 12, they're doing something similar. Their catalyst makes syngas, as far as I understand, and they can then convert that into other products like SAF. New catalysts that are being developed are making 2-carbon molecules. Generally, it's not 100% selectivity, but there are improvements happening every day, at least in the literature that I'm seeing. And interestingly, I think interfacing that with biology could be a unique opportunity, because the most important thing I think we need to see there is the conversion efficiency into usable molecules. It doesn't necessarily have to be 100% conversion into just one thing if the next step in your process can handle a mixture. I'm curious about whether biology could do a good job of that. Right now, the output of those experiments tends to be maybe it's some ethanol, some ethylene, little methane, maybe hydrogen. If you take that mix and you can find a biological solution to that, why couldn't we consume all of those molecules in parallel? And then you could focus the electrochemistry on just efficiently using the energy and the inputs there to convert it into something that biology could take as a mixture.
Yeah, it's funny because I was imagining 10 microbiome of engineered organisms that each are able to consume a different output. And as you said, Noah, produce one molecule at the end, which is a wild idea. It just seems very efficient.
Yeah, you can maybe even put all those pathways in a single bug.
Right. Yeah.
I mean, I don't know. Then again, this is thinking a little further out. But we're excited about ethanol because we do see that it is something that could be reached through multiple pathways. They all look attractive from an environmental perspective, and it's going to shake out in different ways based on cost, availability, logistics, and supply chain of that type of feedstock. So we see that there's going to be a shift moving away from the petrochemical industry. The question is, what's coming next? What makes the most sense to invest in next? And we think ethanol has a really strong position there.
Yeah, so ethanol is a feedstock, and you mentioned E. coli as a microbe. E. coli has been very well studied. This is always something that when I talk to CEOs of companies, they're like, oh, we're just laser focused, which is completely fine. But just entertain me, it helped me visualize. Have you thought of using other microbes? Would there be a benefit if there was a microbe that could do a certain thing? Any thoughts on using different microbes?
Yeah, my perspective on that is like in all of the above. I've spoken at conferences a couple of times where the person on stage before me talked about how terrible E. coli was and we should never use it. And why does everybody try to shoehorn every pathway into E. coli? That's not the way to do it. I'm not so wedded to one strategy or another. I think in the end, what gets commercialized is what makes the most sense from an economic and environmental perspective. Sometimes you can go out in the environment, find a microorganism that'll consume a feedstock and make a certain product. And if that's the most efficient way to do it, then that's great. I think the advantage of using strains like E. coli is, you mentioned it's well understood and well studied. It's also been scaled up huge industrial scale over and over again. So there's a lot of industrial knowledge already around that process. And that's an expensive thing to have to relearn if you bring a new microorganism to market. Scale up is, of course, expensive. It's very large volumes and lots of people and expensive equipment to borrow or to build. So I get the perspective of being excited about a new microorganism. And certainly there are things that E. coli is not perfect for, but it's a different set of risks depending on the particular feedstock and product and process that you want to run. Maybe it's the right set of risks or maybe it isn't. I heard a rumor recently, I don't know if this is true, I heard a rumor recently that even the big amino acid producers that used to mostly use C-glutamicum for making a bunch of amino acids have shifted to using E. coli. They've been operating for decades. Why did they do that? I assume it's just efficiency and cost and robustness of the strain and the process.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business.
So you mentioned challenges in scaling, and specifically you mentioned that E. coli has been scaled successfully repeatedly over the decades. But are there any challenges that industrial microbes have faced when it comes to scaling? And how have you guys overcome those challenges?
Scaling is tricky because I think it kind of highlights the fundamental chicken and egg problem that you have, especially as a startup. You get started, you have an idea, you look for funding for that. When you ask for funding, people say, well, is that what customers actually want? Is someone going to pay you for that? So then you go to the people who might pay you and you ask if they want to support that work or if they would buy it and they want to see samples. Well, you can't give them samples until you have some technology, and you can't provide that sample in the scale that they want until you've done it in a larger bioreactor. And so you get stuck in this three-way chicken and egg problem. We've been fortunate enough to find ways of slowly getting to that point in some cases, and now things are really picking up. And I would love to highlight that I think the two biggest factors there are investors who have that long-term vision, the kind of support we've gotten from government agencies like ARPA-E and Biomed recently. That can really break that cycle where you can get stuck always trying to scrape by. For us, that has been what's made the biggest difference. So today, we're at that point where we're scaling up. We're generating many kilograms of product that we're sending out to different partners for testing. Like I said, it's expensive to do that. So the support from groups like Biomade has been critical, and being able to leverage the expertise of people, in our case at IBRL in Illinois, who've been terrific partners for us. We've pretty quickly been able to take the work that our team has done at the bench scale, prove its robustness, and bring that almost 1,000-fold larger fermentation volumes and see very similar robust behavior. Just in the last 6 months, I think we've made a huge step change there.
That's amazing.
Yeah, very exciting. The Biomade, we would love to learn more about that whole story. What are they looking from Industrial Microbes in terms of milestones? Are we still talking about acrylic acid and acrylonitrile? Is that the chemical that you're scaling up? So we'll love to hear a little bit more about that.
We're working with Biomade on 2 different projects. One is the conversion of ethanol into poly-3HP, so specifically looking at using that as a biodegradable bioplastic polymer for different applications. And actually, at this moment, my co-founder, Liz Clark, is in Illinois working on purifying that polymer using a process that we developed. Really excited to bring all that material home and begin our testing with it. The second program is around acrylonitrile for sustainable carbon fiber, and that is starting up over the next few months in a collaboration with some folks at Georgia Tech who are experts in carbon fiber, and a group at Firmworks to help us do additional scale up, hopefully to an 18,000 liter fermenter that they have that we'll be able to run our process in and use that material to then generate acrylonitrile and make actual sustainable carbon fibers. So obviously that's really exciting to have 2 different products that we're working on at the same time, and to reduce the emissions from both of those processes would be really valuable for us and the partners we're working with.
Wow. What kind of carbon fiber are we talking about? Are they multi-walled carbon nanotubes?
No, it's just made through the polyacrylonitrile process, but it's the high performance carbon fiber that goes into consumer goods like lightweight bicycles, but is also really critical for lightweighting vehicles like airplanes, cars, and probably from the government's perspective, drones.
Spaceships.
Sure. Yeah,
Yes.
I'd love to make some spaceships. I started life as a physicist, so if you don't get involved in that if you don't get excited about spaceships.
Yeah, now full circle.
Yeah.
Full circle. Here we go. You're making spaceships.
Yeah. I'm super excited about all of that news, Noah. We are going to have Doug Friedman of Biomade on, so we're very excited. We've had a number of biomanufacturing companies on the podcast. Just curious, what's different about your approach, and why is it necessary to have different approaches when it comes to biomanufacturing?
The main thing that differentiates us is the focus on using different feedstocks. So we were talking about ethanol for a while. That is a way that we can diversify our process away from what other folks have been looking at. We think there are good techno-economic reasons to do that give us an advantage in the market. But also, it allows us to just have a diversity of approaches, not just from other biomanufacturing, but from the chemical industry as well. For example, in looking at our project to get to acrylic acid, right now, there are, I think it's 5 acrylic acid plants here in the US, and 4 of them are on the Gulf Coast. So probably heard of the various things that have caused disruptions in the chemical industry in Texas, whether it's freeze, a cold weather event a couple of years ago, or when they have hurricanes. If that disrupts 1 or 2 of those plants, it's a big change in the supply chain. For us to diversify the feedstocks and the locations and to distribute that a little bit more throughout, in our case, US manufacturing, that provides a bunch of different useful benefits. It allows us to insulate the supply chain from some of those types of disruptions that you can imagine in the future beyond just weather events, but also geopolitics and other things that if you listen to the news, you could imagine that tariffs against China could become a very big issue for inflation here in the US for all the different products that currently buy, and a lot of raw materials that we're buying now come from China. To be able to improve domestic manufacturing is another really important aspect of what we're doing, and especially because of the US's strategic advantage in ethanol production at a low cost with an abundant feedstock, with all the infrastructure we have. We think that really positions us and the US economy to insulate ourselves better from those kinds of supply shocks.
Yeah, we've spoken about distributed manufacturing quite a few times. We had Anthea on. They also won a Biomade award to develop active pharmaceutical ingredients, which is very exciting for them. Of course, I mean, that in theory sounds great. It's distributed, you could de-risk all of your supply chain. But what other infrastructure changes would help accelerate the adoption of biomanufacturing? Obviously, funding the infrastructure would be, let's say that's definitely going to happen. But can you tell us a little bit more about what you think is required to accelerate the adoption of biomanufacturing?
I think a lot of it gets into the details of what does that actually look like. In the case of scale up, obviously it's really important to, as a startup with limited resources, to be able to access the type of equipment that you need for that to be affordable and when you need it. So in terms of infrastructure, it's not just the fermentation capacity, it's also the downstream and the expertise. One of the projects that we've worked on, there's literally one piece of equipment in the whole US, and we need to rent that and align that works with the other projects that they're trying to rent that out to, for example. That's a bottleneck for us. If we can't get access to that, that's a big problem. There is more interest these days in trying to solve that problem, both with funding from government groups that are seeing that as a strategic challenge for domestic biomanufacturing. And I think also from the industry perspective, our lead investor in our seed round, First Bite Ventures, the managing partner there, Veronica Breckenridge, has recently been working on a project called Biowell. It's an emerging example of exactly what you're talking about. They're trying to put together the right pieces to help companies like us in the scale-up process, bring together the expertise and the downstream pieces of equipment, and then also connect that to, say, the chemicals industry in Houston where they're setting this up. And being able to show that connection to the rest of the value chain is also really important in getting pull through from the eventual customers, because that creates the demand that motivates everyone else in that value chain to move towards these more sustainable processes.
Yeah, I'm glad you're mentioning that because there's a bunch of points that you've made that I think are really important. Like this idea of being dependent on 4 facilities in the Houston area is a nightmare. And then the fact that you guys are dependent on one piece of machinery that no one else has in the United States, that's just crazy town. That is so insane. I want to know what that machinery is and who's out there. Why aren't they making more of them? Why aren't more of them available? And then this idea of being able to look at the entire value chain, we're talking a lot about that in terms of ecosystem building. You've got an innovator like you guys, you need infrastructure, you need end customers. How do we put all those people together? It's something that we see that there's a big need for. And just like you've been talking about all these waste products that can be turned into ethanol, that's something that we've talked about a fair amount on Grow Everything. But maybe you can give our audience a little bit of background on why does it matter that we use waste as an input? And maybe give us some examples of the way you guys are approaching it.
I mean, right now, there are so many things in our everyday lives that we don't even realize where they come from. I mean, like 99% of people probably don't even understand how many products come from the petrochemical industry. I was just thinking about this the other day. Like, imagine if you buy a new car, what is it made of? Where do those materials come from? It's obvious that maybe people know that plastics come from the petrochemical industry, but in a car, there's the paint and the coating on the outside. That's a petrochemical product. There's the foam in the seats and the fabric that might be synthetic. There's electronics in there that, in order to manufacture those, required solvents and photoresist. The deeper you go, the more you realize how interconnected all of those things are with the petrochemical industry. But it's not a matter of can we change? It's really when. The definition of it being sustainable in say, a biomanufacturing process or using renewable feedstocks, there's just no way that you can do that with oil. At some point, you can't do that anymore. Eventually, it will be an economic thing, but just from physics, we will run out of oil someday. And so we'll have to start from something else. And the question is really, when do we do that? And I would argue, primarily for environmental and climate reasons, we should be doing that now. It's not going to be easy. And it's a huge industry that needs to be disrupted and replaced with fundamentally different technologies. The way we see it is we should change as little of that as possible, but you have to start at the top and change the feedstock. And then you have to find a way to efficiently turn that into the same chemicals that end up in your car, for example. And that's where we want to sit, because that is a huge opportunity. And we think that biomanufacturing has a unique role to play there by virtue of it being cost effective and efficient and low emissions and being able to take advantage of low cost electricity in the future to power everything. It's very different from the way the petrochemical industry works today, where they basically power everything from a barrel of oil, and the molecules, the atoms, they all come from a barrel of oil, and then the heat and the pressure and everything that's generated to do the reactions is also coming from burning fossil fuels. We just need to change all that. And it's not a matter of do we have to, it's just when.
Yeah, and you've thought about this a lot. You've published 2 books, one on moving the world beyond petrochemicals and the other on the ROI of waste. So can you tell us more about those and what motivated you to publish these and what have you learned from the response? And of course, we'll link to them in our show notes.
I think what we were realizing going through the process of looking at where the trends are in the world, as I was trying to describe earlier, if you're going to build a new chemical plant, it could be around for 30, 40 years. That's a difficult job predicting the future. What are things going to look like? But you can see what the macro trends are today. With the challenges that we have, I think especially with respect to climate change, we see that the chemical and material industry, they know that they need to change. They just don't quite know how to do it. Nobody really wants to be the first one to jump out and make a mistake. So there's a lot of reluctance from the folks at the top of the value chain where they're starting from oil and trying to figure out how do they change, how do they reduce their emissions. Most of what they come up with are, frankly, incremental changes. But I don't think that's going to suffice. And it's a big and important industry. And it's hypocritical of us to point a finger at them and say they're doing a terrible job because I'm buying those products. I mean, this is a plastic pen, you know? So how do we solve that problem in a way that's going to work over decades? That was what motivated our view of trying to zoom out and take a big picture look at this. What needs to get done? And who is motivating that and paying attention to it? And one of the things that we've understood from diving into that and from the response we've gotten is that the companies that are closest to consumers are the ones that are paying the most attention to things like climate change and carbon emissions. And that's because they hear from regular consumers like us that we do care about that. And at the same time, if you ask people, do you want to pay twice as much for the diapers that you're putting on your kid, you use for 2 hours and then you throw out? Most people don't. So we have to come up with solutions that are zero emissions and are at the same cost as it takes to make them today. And if we do that, of course, you go to the store and you buy like the green version or the old version. You're going to buy the green version if it's the same cost and the same performance. So it is a big challenge. But what we've heard is the consumers want it. And so the companies that are closest to the consumers want that. We just need to figure out how do we then stretch that motivation all the way up to the top of the value chain? Because there are sometimes many companies in there and that motivation decreases a little bit each time you go back up the chain. That's one of the big things that we're trying to help people understand is that we have to get there. It's a matter of when. We can build the technologies to do it. On the fundamentals, it works and it can be cost competitive. And we just need to engage the entire value chain to do that and to work with that industry more broadly. And then there will be huge opportunities there for those who are willing to go out and help us build that type of new technology to replace what's already out there, but isn't going to do the job in the future.
Yeah, that's super exciting, Noah. Based on that and everything you've told us, what do you see the milestones that you guys are looking to accomplish in the next year or 2 years?
Yeah, the next year is going to be big for us. We've set a bunch of technical milestones. Our team over the last 12 months has hit every single one of those exactly on time. And I'm super proud of them. They have worked really hard and been very creative in solving those problems. And so we've set goals for this year that are mostly driven by our techno-economic model so that by the end of this year, we're proving in the lab that we can be at technical metrics that if we achieve them at large scale would put us in rarefied air for being cost competitive on those products. On the commercial side and the scale up side, we want to set up partnerships with some of the major chemical producers, especially in acrylic acid and acrylonitrile. For scale up, we are continuing to test our process at larger and larger scale, generate larger samples. And we've been working with a group called DIBC. I don't know if you've had other folks on the podcast that have been involved there, but it's the Defense Industrial Base Consortium. So it's part of the Department of Defense that has awarded these contracts that are about roughly $1.5 million to plan out what does it look like to make your first commercial facility. And we're in the middle of that project right now. That will help us to have a much clearer view of what it's going to take to build a small commercial plant and what the economics of that will look like. So by the end of this year, we'll have those plans in hand and a much clearer view of what it will cost on both the CapEx and OpEx side to do that. The new program we're bringing on to work on sustainable carbon fiber, hope to have that mostly completed by the end of this year and have actual carbon fiber produced from our process. At the end of the year, I think it's likely we'll be entering a Series A fundraising process. So we'll be looking to expand the impact of what we're doing to larger scale and to new products potentially. So lots of plans for 2025. Really excited about that.
Yeah, you should look to the commercial space flight people, Blue Origin and SpaceX. But hey, look, I'm making some carbon fiber. Maybe they'll open up their checkbooks for you at the end of the year.
If you have their phone numbers, I will take them offline. Yeah.
Yeah, we'll talk. So this is so exciting because we love the whole waste to value idea and of course making valuable products. I mean, carbon fiber, wow, I'm still wrapping my head around how big this can go and I'm very excited for industrial microbes. But beyond your current work, what developments in synthetic biology most excite you?
There's so much going on in the field right now, and not to leave out any particular topic, but I think two things come to mind. We mostly have our heads down in the biomanufacturing space. So in that area, one thing I'm particularly excited to see would be the ability to design enzymes with new chemistries. Sometimes when we're designing a new pathway, we'll just look at what else is already out there in enzyme databases. But with the advances that have been made in protein design, I think we're closer than we've ever been to saying, hey, I would like to transform X into Y. Could you dial up an enzyme that could do that with very high specificity, for example, and preventing those off-target reactions so that when I throw it in my cell, it does exactly what I want. That's an area that I'm particularly excited about. The second thing I'm excited about, I'm sure you've done a lot of conversations with people about AI and machine learning and how that crosses over into bio. I'll admit that I tend to have a knee-jerk reaction against whatever is the next big thing because the hype and the wave always crashes. So in this case, I don't actually think that that is as true as in some prior waves. I do think that the computational tools that people are building are super exciting. Where I really get excited is when it's coupled with the large data sets that you really need to generate something of a lot of value. One area where I feel like biology does have an advantage over some other fields is the enormous amount of sequence data that has already been generated and that continues to be generated because of the advances in how low cost it is to do sequencing. Those two things coming together has been amazing. And then research labs that have come up with tools that allow you to generate really large data sets, I think will be positioned very strongly. So if you have like a native bio platform that generates enormous data sets that can be used for machine learning, that's an area where I'm particularly excited about. Have you all already talked to the folks from Abalone Bio?
No, who's that? We want to talk to them.
Yeah, you should. Yeah, I've known their CEO, Rich Yu, for probably 20 years at this point, and they have an incredible story. So if I could just point you to chatting with them at some point, I'm super bullish on what they're doing. And I'm sure you'd have a really great conversation there. And they have an interesting overlap between the machine learning side and the native bio platform and the therapeutics. And then there's the synthetic biology that they've done to build that platform, I think is really unique and positions them in a great way. So yeah, would love to hear an hour-long conversation between you all and Rich. I think you have a great time chatting with him.
That sounds great. And just as we close this conversation out, I will mention that synthetic biology is featured on this week's Science Friday. He's talking to Drew Endy about mere peptides or mere proteins, and they actually talk about creating a mere E. coli and why that's a bad idea and why Drew Endy and all these scientists came together against that kind of building. I think what you're saying about machine learning is just so interesting. Like Erum and I were talking about this because on Monday, I had been on a call where these guys from Molecule were talking about their biotoken and porting it over to the Solana blockchain. And they had this whole conversation about using agents for drug development. And it was just one of these mind-blowing moments where I was like, I don't know if I'm ready for all these agents being loose on the internet doing stuff. And have I read any science fiction where that's actually the case? I don't feel like I have. But it's very exciting times. And it's like we've known each other for a while, Noah, and I just love seeing the progress and how much progress you've just made. It feels like in the last couple of years, it's just accelerated.
Yeah, I mean, I think that's just how it happens sometimes, that you're grinding away on something and then you get some progress in the lab, and that leads some investors get excited about what you're doing, and then a grant comes in from, I don't know, ARPA-E or Biomade, and then you hire a few people and they bring all this new perspective and it just starts to snowball. And that's the way it's supposed to work. It suddenly feels for us in the last, I would say, 6 to 12 months, it has a new feeling to it. And the reaction that we get when we go to a chemical company and describe not just what we could do, but what we're already doing, we're seeing different looks on people's faces, so to speak. They're more serious about that. And it brings back to a lot of the things that we've discussed today, that getting to the point where you can actually put something in somebody's hand that is large enough for them to believe that it could be part of their future. Like, here we have kilogram of this product. We can work together and turn that into a ton, and then we can turn that into a kiloton, and that can start to have real impact. It's the point we're just getting to now, so it feels like a really exciting time. And all the infrastructure and biomanufacturing momentum that we have here in the US now, I think, is starting to recognize that getting companies to the point that we are just at now should be a major goal to see then where does it go from there.
Yeah, that is extremely exciting. I could feel it. I could sense it in you, Noah, because you've spoken for the first time a couple of years ago. And here we are. I can't wait to hit my first set of golf clubs made from Industrial Microbes acetylnitrile.
We'll put you on the list. Well, first, are you a golfer? Are you a big golfer?
I mean, not big, but I dabble.
Uh-huh. All right. Next time you're out here, we'll go play the course here in Berkeley. I've only played
Nice.
once in 10 years, so I will be measuring my score by golf balls lost in the water hazard or whatever, but that'll be fun.
Oh my gosh.
Yeah.
Awesome. Wonderful. Well, thank you so much for joining us on the Grow Everything podcast, Noah.
It was a great conversation. Thanks so much for having me.
Yeah, thank you.
So, Karl, what did you think of that episode?
One of the things that Noah made clear, he and his team are a testament to how long it can take to develop science and products. I mean, they've been at it for like 10 years, and I know they've struggled. So I was really happy to hear when they had raised and to hear about the progress that they've been making. So I thought that was fantastic. What did you think?
Oh, I loved it. For us, every time we speak to founders and CEOs of biomanufacturing companies or industrializing biology, we learn so much about how they are differentiated and their approaches. So it was great to hear that he's looking into the carbon nanofiber space. There's so much that could be made. We talked about making spaceships. I mean, hello. And, this was a world that I lived in 15 years ago, which is actually about using carbon waste emissions to make carbon microfibers, enough to be dangerous. So I was trying to pull out some terminology about the types of carbon nanofibers. I was like, oh, multi-walled carbon nanotube. But he was like, relax, Erum, this carbon nanofibers.
We're just making the material. Don't worry about it.
Exactly. So that's cool. And then, remains to be seen what else he has going on in the pipeline. But it's really cool that they got the support from Biomade, that he's at this inflection point that was hard won. I mean, 10 years going at it, and now they're really leveling up their capabilities and taking all the knowledge that they have gained over 10 years and being able to apply it to scaling up biomanufacturing. Is just phenomenal. I can't believe we are here. It's going to be exciting to see how Noah, Industrial Microbes, start partnering with other organizations, getting new customers, getting new clients, and being able to be a source to point to, saying, hey, look, biomanufacturing is working. Look at what Industrial Microbes is doing. This is great for the economy, and it's great for making new products. And whatever mission you have, whether it's making products for your local community or going into outer space, biomanufacturing is there for you. So please, let's keep taking a look at this fascinating technology and bring it into the mix of being able to make all of our goods, services, energy, everything that we need to sustain our lives.
Yeah, it is advanced local manufacturing.
Oh, yeah.
And I think that if you're interested and you haven't listened to it, we've covered a fair amount of biomanufacturing episodes. We had Edward Shenderovich of Synonym. We had Christine Smolke of Anthea. Even Joshua Robinson talking about using moth larvae as biomanufacturing vessels. Mm-hmm. And we're going to have a lot more of this going on because it is a very interesting space.
Yes. So thank you so much for listening. Let us know if you have any questions We have our contact information in the show notes. Sometimes you just want to ask a question by voice. So you can give us a call. The Grow Everything hotline is in the show notes. We would love to hear from you. Stay tuned for the next episode.
That's the pod.